Hello there. We begin Chapter 5 today with polynomials and trying to review some properties of exponents that I'll assume that you saw a little bit in Algebra 1. Let's begin with just some very simple reminders of how these exponents work. If we have, say, a squared times a to the fourth, well, a squared means a times a, and a to the fourth means a times a times a times a. And so that's the same as a to the sixth. And so what we notice here very quickly is that when we're multiplying, here's the multiplying, variables with exponents on them, what we wind up doing is adding the exponents. So, a couple of quick examples. A cubed times a to the fifth equals a to the eighth. How about if we put a couple together? A squared times a to the fourth times a to the third, that's going to be a to the ninth. And if we make it even more interesting, if we have something like 2x cubed y squared times z, and we multiply by 3 x to the fourth y z cubed, well, that's going to equal, just multiply the same things together. So 2 times 3 is 6, then we multiply the x's, we multiply the y's, and we multiply the z's. So take a second, what do you think you get? 6 x to the seventh, y to the third, z to the fourth. And just as a quick reminder, when you see no exponent there, the exponent that is intended is just a 1. And so we add the 1's up just like we would add anything else. Alright? So our big rule is, if you have a to the m times a to the n, the result is a to the m plus n. Alright? So there's our first big rule. Now let's look what happens if we are dividing. So if we have something like a to the fifth over a squared, okay, well what that means is a times a times a times a times a, that's a to the fifth, over a times a, that's a squared. So we cancel each of these out and replace with a 1, cancel each of these out and replace with a 1. And so what I'm left with is just a cubed. Now you should be able to follow that if I have, say, a to the ninth over a to the fifth, and I do the same thing, that's going to be a to the fourth. And if I do something a little bit more complicated, like 6a to the fifth, b squared, c to the fourth, over 2a squared times b to the first, c squared. I just divide things that are the same. So I'm going to get 3. Let's get rid of that. 3 a cubed b c squared. And so it's pretty easy to see what this rule is. If you have a to the m over a to the n, what you're going to have is a to the m minus n. So with multiplication you add, with division you subtract. So let's pick it up one more level. Suppose we have something like this. A squared cubed. What that means is a squared times a squared times a squared. And now we're multiplying, so we add the exponents, and we get a to the sixth. And please notice that 2 times 3 is 6. So when you have a power raised to a power, you're going to wind up multiplying the exponents. So that's the rule that we'll just jump to right now. If you have a to the m, and it's raised to the n, then that's the same as a to the m times n. Now that's our third rule real quick. So let's practice with some examples. So if you take a look at this example, all we do is we apply the rule that we just looked at, and that's going to be a to the 15th over b to the 12th. And I suppose we could make this as a rule also, but after a while these get to be pretty simple. And this rule would simply be if you have a over b to the m, that's the same as a to the m over b to the m. Alright? So let's take a look at this example, which looks pretty bad to begin with, and this will be the last one we'll look at. So we begin by simply working within the parentheses, and we know that 6 goes into 24 4 times. We have x to the 7th over x squared, so we subtract there, and we get x to the 5th. We do the same thing with the y's, and we get y squared, and all of this result is being squared, and so 4 squared is 16. X to the 5th squared, we multiply the exponents, and do the same thing here. Right? And that's how you deal with exponents in some of those simple cases. So we'll continue to expand what we know in future sections. See you then. Bye-bye.